All right, welcome back. This is the third of what will be three videos about analyzing camera trap data with Tableau. And this time we're going to be looking at sub-project or array level data. And this is, again, the Snapshot USA data set where we had 110 different places that somebody ran a camera trap or ran a bunch of camera traps. And then at each of those sites, each of those arrays or sub-projects, there were many camera traps. So in the first video, we looked at each row of data was an individual picture. In the last video, those pictures were summarized per location that a camera was. And this time, those are summarized per array. And so instead of having, last time we had about 1,500 dots on the map from each place a camera was, this time we'll have 110, which is how many different arrays we had, right? So again, we'll drag, in this case, we have an Excel sheet, and we'll drag that into Snapshot USA. And in this case, no data shows up right away because we had two sheets, okay? We have detections and we have sites. So detections is a sum of how many detections there were. So if a coyote walked in front of a camera twice while it was out, that would be a 2. In sites, it's a record of how many sites they detected at. So if a coyote was detected at 3 out of 17 sites, the answer would be 3, even if it was detected multiple times, right? So those are fundamentally different ways that you can use camera trap data. And so the different worksheets here. If you were going to use the detections, you would standardize by dividing by the survey effort to get an estimate of detection rate. How many times on average across all the cameras in an array were coyotes detected per day? Now, if you use the other data sites, you're getting naive occupancy. So what percentage of the sites were occupied by a species, and you would standardize by the number of cameras. So since we did detection and detection rates in the last video, let's do occupancy in this video. And you can't do occupancy at the individual camera trap level because that's only one camera trap, right? It either was present, it's either 0 or 1. In this case, we're looking at an array. And so if they had 20 cameras, if 10 of them are occupied, then that would be 50% occupancy. And so that's why you need to do that at this per sub-project level. Okay, so let's drag sites over. It says drag tables here. Now it's loading it up. And in this case, right, there's only like 109 rows because each row is a project, a sub-project, sorry. And you can see how many days total all the cameras were run and how many sites. And so in this case, when we're standardizing the detections per site, the number of sites, we're dividing by the number of sites, not the number of survey days, right? So if you were doing detection rate, you would do survey day. If you're doing occupancy, you're doing number of sites. And then you've got these other things that we were looking at before: population density, GPP, cultivation, nearest buildings. In this case, right, so the nearest building is an average of all the cameras. So last time we were looking at each individual site, what's the nearest building? And in this case, we're taking all those and getting the average value for this sub-project. And then we've got the detections. So how many cameras, how many sites were these animals detected, right? So let's find raccoons. Should be northern raccoons. There it is, northern raccoons. And let's create a calculated field. And we'll call this just call it OCU raccoon. And that's going to be sites of northern raccoon divided by sites, right? That's what it's called, right? It's called sites. It's called n sites. N sites. Okay. So this is how many sites were detected by raccoons. How many sites were raccoons detected in an array divided by the total number of sites that were monitored in that array. Cool. Okay. And was I going to do anything else? Let's just start with that. Okay, so now let's go into the worksheets and let's do a map. So we've got latitude and longitude. Drop those into rows and columns. Turn it to dimension because it always wants to average them. Okay, so now we've got our map, and we can look at raccoon occupancy, and we can see, maybe we change the color array. Where are there a lot of raccoons? There you go. You can see the raccoon center of the world. So I don't like that color. Meant to do this one. Okay. Now blue is a lot of raccoons. So a lot of raccoons in the east, high occupancy. Occupancy can never be higher than 100, right? You can never be more than 100% of the cameras. But there it is. Now the other thing I wanted to do I'm going to make these a little bit bigger, is let's explore some of the covariates. So instead of the animal covariates, let's look at GPP. So here is GPP, gross primary productivity. We should probably make that a green scale because that's generally sort of plant growth. So now green is high and yellow is low. And so you can see here's where there's the most primary productivity, in the places that are wet and warm, basically. So some of these desert sites have low productivity because there's not much vegetation that grows there because they're too dry. Some of these wet Pacific Coast sites have really high productivity. And you can see how that sort of varies across the country. So that's pretty cool. When you're doing this, if you want to mess with the colors, you can go to advanced and you can change. Oh, it doesn't work for this one. If you have one that's diverging, you can change where the center is, right? So if I do it like this, it's going to look like that. The center is about in the middle. But if you had some value, say, oh, I want to see, I want to see another area better. You could say, okay, well, let's make this 5,000. And then, oops, it messed it. What did I do wrong there? Oh, I did 5,000. There we go. And it'll kind of change the scale. So you have some ability to change that. So we've looked at GPP. Let's look at human population, drag that into color. Again, the scale, this blue scale is so boring. Let's make red, green diverging, but now we'll reverse it because we want red to be where there's lots of people. And oh, well, you can't even see it. This is another place. So there's some place there that's got tons and tons of people in Baltimore. And oh, this is some, we should make it a dimension. I don't think that'll change things, not really. So this is one where we need to advance. We need to make the center, let's make the center maybe 1,000 people per, and then you can also say maybe use full color range. Will that help? Oh yeah, there we go. So now you can see the real hotspots, right? So we've got some data from Seattle, some data from Detroit, and some of these other places. Baltimore has really high density. Some sites in Connecticut do, and you can zoom in to see some of these. If you wanted to label them, you can grab, where is it? Site, is it called? No, I think it's called array. No, what's it? Oh, we didn't give it a good name. What was it called? Row labels. All right, well, it's called row. We can rename this and call this subprojects. All right, above that. So anyway, if you want to label your map, you can drop that into label, and now you'll see the labels. And maybe you don't want them to be shown, but it'll still show up if you float over. So there's Michigan, there's our Massachusetts, Bridgewater. Okay, so check that out. Check out our different covariates and see what you're dealing with, how they map out on the map. Always good to do that. And again, each one of these dots is one array, right? So it represents a whole bunch of different cameras at that one site that you can view in the other data set. Okay. So what do we have here? Let's check out, let's make a new sheet and let's find our raccoons. What's controlling raccoon occupancy? What's correlated with it, let's say. So make this a dimension. There's all the raccoon occupancies. And let's check out humans. We know population, we don't want sum, we want dimension. So now we can see raccoon occupancy versus human population. Now, so much of this human population is lower, right? And so this is a good example. Let's get rid of this and let's add log human population. That's probably going to be, that might show more variation. And then let's go to analytics and we can drop the trend line in linear. And you can see, oh, there's a pretty positive trend line there where occupancy of raccoons goes up in human population. You can see here where you have high human population, occupancy of raccoons is quite often over 70, 80% of the cameras that get a raccoon. That's pretty impressive. You can see the p-value is pretty strong, not a real tight R-squared relationship. And you could test, I wonder, would it be better if we do a, let's just remove. Let's I want to drop that line in again and make it logarithmic. Is it any better? No, not really that much better. All right, we'll undo. Okay, so now we've got a cool, interesting relationship. We could also try some other things instead of population density. What if we try, what about farmland? Cultivation. Make it a dimension. Oh, that's interesting. That looks like, so let's try dropping in a trend line. Linear. Yeah, yeah, definitely. You can see the areas that have high cultivation have really high raccoons, right? Let's try that trend line. I just undid. Undo is your friend. That logarithmic relationship might be an even better fit. So that's interesting that there definitely is any of these areas that have high cultivation, over 25%, have really, really high raccoons. So that's pretty interesting. But the next thing I want to do is show another type of analysis. And so in this case, we're going to make a group. And so in this group, I want to make a site. I want to look at raccoons where there are and are not apex predators. Okay, so I'm going to make a new field. So just grab any one of these. It doesn't really matter to create calculated field. And I'm going to call this apex predator. And this is just going to be, so it's going to be Puma, the sites with Puma, plus the sites with brown bear, plus the sites with gray wolf, plus the sites with red wolf. Okay. And then divided by the total sites. Nope, click the wrong button there. Okay. So now I'm going to make a new sheet, and let's get our rate of raccoon, or our occupancy of raccoons. Now, it's naive occupancy. We haven't adjusted it for detection rate. And we don't want it to be sum. We want it to be a dimension. So there's all the, now let's look at how that varies in places. Oh, wait, no, first, okay. Sorry, jumping ahead of myself. Let's get rid of this. You can see, what I want to do is first we need to make the predator occupancy. I want to make that a 0, 1. That either there are predators or there aren't predators. So I'm going to say create a group, and anything that has greater than 0 is going to be apex predators. So that means that there were apex predators there, right? Now, the occupancy that I calculated is not, you can't really calculate occupancy across species like that. But just to note whether there was an apex predator there or not, it works fine, right? So apex predator present, and then the ones that had 0, we'll create a group of 1 and call it no apex predator. Right, so what we've done, and I'm going to call this apex predators, is we've just created a group that is all the sites that have apex predators present and all the sites that do not. So now I want to know, how does that affect raccoon occupancy? We drop apex predators up here, and we make it a dimension. Oh no, sorry, I grabbed the wrong thing. I need the group. Okay, apex predator group, drop that in. Now we have our two groups where no apex predators are and where there are apex predators. And you can see the values for raccoon occupancy tend to be a lot lower. But we can, let's go to analytics and say box plots now. So before we were doing trend lines, but now we can drop box plots on, and it'll show you a box plot for the average of these two. And so you can see the average for no predators, for predators present, is very low. It is, or the median is 0.2, whereas the median for places that don't have apex predators is 0.5. But you can see the variation definitely overlaps, but it's a pretty interesting pattern here suggesting some differences, but as we were seeing in the other graphs, raccoons are also affected by people or correlated with people. And so this is, and predators are probably as well. So this would be a bit of a trickier one to untangle. To what extent is it predators? To what extent is it the human dimensions? But at least you've been able to go in with Tableau and explore and find these patterns. And now you sort of have a focus of where to go next for some more complicated things. So of course, you'll want to save this up to Tableau so that you can share it with friends and say, what's going on with these raccoons? We've done that in the last two, so I won't do that again today. But hopefully this has shown you how the sub-project level data works, a little bit about how to make groups, how to do some box plots, and how to start to look for correlations between these covariates. I hope you enjoyed.